Hello class. Today's topic is extended from the first lecture, the introduction of chromatography. Now after the introduction to chromatography and the chromatogram, next is classification of chromatography. Now classification of chromatography can be done on the three bases. First, on the basis of interaction of solute to the stationary phase. Second, on the basis of chromatographic bed shape. And the third, on the basis of physical state of mobile phase. Now, dealing with the first, on the basis of interaction of solute to the stationary phase. Now here, solute is the sample which we want to separate, the components of the sample which we want to separate. Now the stationary phase, as we know, there are two phases in the chromatographic separation. First is mobile phase and second is stationary phase. So on the basis of interaction of solute, how our sample behaves with stationary phase, it is classified into four types. First is adsorption chromatography, second partition chromatography, third ion exchange chromatography, and fourth is size exclusion chromatography. Now on the basis of chromatographic bed shape, mainly it is divided into two types: two-dimensional bed shape or three-dimensional bed shape. Three-dimensional bed shape is used in column chromatography, as we have discussed the first ever experiment of chromatography done by the scientists. Now the two-dimensional bed shape is used in two types of chromatography, that is thin layer chromatography and paper chromatography. Now third type of classification is on the basis of physical state of mobile phase. If the mobile phase is liquid, it is known as liquid chromatography. If mobile phase is in supercritical fluid form, it is called supercritical fluid chromatography. If mobile phase is in gaseous form, it is known as gas chromatography. Now moving to the initial classification, that is on the basis of interaction of solute to the stationary phase. There are four types. Today we will learn about two types, that is adsorption chromatography and partition chromatography. Now adsorption, there is a difference between adsorption and absorption. In absorption, the solute goes inside any substance. If solute goes inside any substance and it is solubilized, that is absorption. But if solute is adhered to the surface, because it's a surface phenomena, it is known as adsorption. So adsorption chromatography is a process of separation of components in a mixture introduced into chromatography system based on the relative differences in adsorption of components to the stationary phase present in the chromatography column. As we know that in column chromatography there is a stationary phase. In the first ever experiment, the stationary phase was calcium carbonate and the mobile phase was the distilled water and the sample was the leaf extract. Now, what does this definition say? The separation of component in a mixture introduced into chromatography system. Chromatography system means the column based on the relative difference in adsorption of component, because every component present in the sample have different affinities to the stationary phase. It will travel to some place and it will adhere to the stationary phase. So every component present in the each and every component present in the sample have different affinity to the stationary phase. It will travel to some extent, and definitely the travel distance or time will be different to other components. This adsorption chromatography applies to only solid liquid or solid gas chromatography, because adsorption phenomena is an inherent property of solids. Adsorption is only can be done on the solid surface. So adsorption chromatography should have one solid phase, whether it is stationary phase or the mobile phase. Generally, in adsorption chromatography, the stationary phase is the solid phase. Okay. Now you can see the figure of adsorption chromatography. As you can see that this is the column, the irregular shape is the column, and these are different components present in the sample, and they are traveling. Some are traveling just here at the initiation of the stationary phase, some are traveling below the stationary phase, and they are adhering to the, not absorbing into the stationary phase, they are just adhering to the surface. And this is the figure which is depicting the surface phenomena, that is adsorption. Solute adsorbed on the surface of stationary phase. Now, as we have seen this figure in our first lecture also, this is the column, the solvent is there, then mixture of component is there, that is the sample, and the adsorbent, that is the stationary phase. This is the glass wool to protect the stationary phase from wiping out by the force of the mobile phase. This solvent is the mobile phase. So we have seen this. Now, adsorption chromatography is also, adsorption phenomena is used in column chromatography also. It involves the separation of mixture over a column of adsorbent. The stationary phase which is selected is act as an adsorbent packed in a glass tube. The mixture adsorbed on adsorbent is placed on the top of adsorbent column packed in a glass tube. An appropriate eluent is the mobile phase, which is liquid, is allowed to flow down the column slowly. The most readily adsorbed substance or most easily adsorbed substance are retained near the top, and others come down to various distance in the column. And this is the key. By this, the components of the sample or mixture of compounds is separated. Now, moving to the partition chromatography. What is partition chromatography? This form of chromatography is based on a thin film formed on the surface of a solid support by a liquid stationary phase. So, you have to understand the difference between adsorption chromatography or column chromatography to partition chromatography. Partition chromatography will have the solid support, but the main stationary phase or act of stationary phase will be done by the liquid which is on the solid support, which is just there with the help of solid support. So the solid support, the solid act only as the support. The separation component or the separation is done by the liquid stationary phase which take the support of solid. Solute equilibrates between the mobile phase and the stationary phase. So, as you can understand by this phenomena, this figure, this partition chromatography, separation is based on the solute partitioning between two liquid phases. The relative solubility. The principle is the relative solubility. Some part of the sample or some part of, if you take an example of a sample which have two components and have different solubilities. One component can be soluble into mobile phase and other is soluble into stationary phase, which is there with the solid support. So one component will dissolve in the mobile phase and another will be dissolved into the stationary phase, which is also a liquid with a solid support. So this is the basic difference between adsorption chromatography and partition chromatography. In adsorption chromatography, the separation is dependent on the adsorption capacity of the stationary phase and the affinity of components to be adsorbed, or the affinity of the components of the sample towards the stationary phase. So in partition chromatography, the principle is the relative solubility. Some components will dissolve into liquid phase and some components will dissolve into the stationary phase. Now, separation, the principle behind the partition chromatography. Some separation of components of a sample mixture occurs because of partition. Stationary phase is coated with a liquid which is immiscible, which does not dissolve in mobile phase. Partition of a component of a sample between sample and liquid or gas stationary phase retard some component of sample more as compared to other. This gives basis for separation. So affinity of solubility. So difference in solubility which initiate the separation. But there is a condition, the stationary phase liquid should not dissolved with the mobile phase. So should not mix with the mobile phase. The stationary phase immobilizes the liquid surface layer, which becomes stationary phase. So the solid support for stationary phase should be like that. If liquid is coated on that solid support, it should immobilize the liquid surface layer, like converting into gel. It's an example, like converting, like silica, if coated with suitable liquid, it will convert into gel. So the outermost layer will be that liquid, and it will absorb the components of the sample. Mobile phases passes over the coated adsorbent, and depending upon the relative solubility in the coated liquid, separation occurs. Maybe that can be adsorbed or absorbed. It is dependent on the component and the stationary phase liquid. The component of sample mixture appears separated because of differences in their partition coefficient. So now you can understand by this figure, this is the stationary phase, and you can see that there is a liquid coated above this, and this stationary phase made this liquid immobilized, and in this liquid some particles of some components are absorbed and some adsorbed. So solute dissolved in liquid phase coated on surface of solid support. So this form of chromatography is based on a thin film formed on the surface of a solid support by a liquid stationary phase. Solute equilibrates between mobile phase and stationary phase. Liquid means the solute means the sample components equilibrates, means they are divided between the mobile phase and the stationary liquid. Now, partition chromatography is of two types: liquid chromatography and gas liquid chromatography. So mobile phase can be liquid or the gas, but the stationary phase will always a liquid by the solid support. So I think it is clear. If you have any query, post in the private comment section of the classroom.